Geometry 1, Chapter 3, Skill 4. You should be able to create basic two-column proofs that require the CA theorem, the AIA theorem, the AEA theorem, the CIA theorem, the CA converse, the AIA converse, the AEA converse, and the CIA converse. Now the abbreviations, CA is corresponding angles, AIA is alternate interior angles, AEA is alternate exterior angles, CIA, consecutive interior angles. So our first proof, we are given that M is parallel to N, and we're trying to prove that angle 2 and angle 3 are supplementary. And here's the picture. Now keep in mind the same rules that apply for these proofs as our previous chapter. So it's always a good idea to start with a given, and you should always end with what you're trying to prove. So we know our bottom line is going to be angle 2 and angle 3 are supplementary, and our top line is going to be M is parallel to N. We also know that we will never, ever, ever put the word proved or proven or showed in our proofs. That is guaranteed wrong. Take a guess, write something else down, because prove or proven or showed are not correct answers in any of these proofs. So let's start. Two-column proof. Left side is the statement, and the right side is reason. Line 1, M is parallel to N. And the reason, that's given. So we know that M and N are parallel. Well, if we know they're parallel, then we can use the corresponding angle theorem, the alternate interior angle theorem, the alternate exterior angle theorem, or the consecutive interior angle theorem. We're going to be using one of the theorems, not the converse. So let's see here. We want to show that 2 and 3 are supplementary. So maybe starting with something, trying to find angles that are supplementary would be a good idea. Well, look at the relationship between angle 1 and angle 2. They are interior angles. They're inside line M and line N, and they're on the same side of the transversal. Angle 1 and angle 2, those are consecutive interior angles. And if they're consecutive interior angles, then what that means is that angle 1 and angle 2 are supplementary. And that's where we want to go next. Angle 1 and angle 2 are supplementary. And the way we know that, again, is because they are consecutive interior angles, and the consecutive interior angles theorem says that they're supplementary, since they're parallel, don't forget. So consecutive interior angle theorem. Line 3. Now notice, line 1 gave us line 2. So we're looking for something to come from line 2. So what? Angle 1 and angle 2 are supplementary. What does that mean, and how does that help us? Well, this is actually something we've encountered many times. If angle 1 and angle 2 are supplementary, what does that mean? Well, it means that the measure of angle 1 plus the measure of angle 2 is equal to 180. And how do we know that? Because that's the definition of supplementary. That's what supplementary means. Now the issue, though, is that this is angle 1 and 2, and we actually need 2 and 3. So it'd be great if we could somehow get that 1 to turn into a 3. Is there a relationship between angle 1 and angle 3? Absolutely. Look at what they are. Angle 1 and angle 3, right here there's like an X in your picture. and they're on opposite sides of the x. That means that angle 1 is congruent to angle 3. And they're congruent because they are vertical angles. The vertical angle congruence theorem. The vertical angle congruence theorem says 1 and 3 are vertical angles, so they are congruent. Now the trick here is that this row has measure of angle 1, and this one says angle 1. The notation's different, and because of that, it's preventing us from actually being able to do what we need to do. So let's use angle 1 is congruent to angle 3. What does that mean? Well, if angle 1 is congruent to angle 3, that means the measure of angle 1 equals the measure of angle 3. And how do we know that? It's the definition of congruent. Now it's kind of nice because look, line 3 and line 5, they have something in common. They both have a measure of angle 1. And because they both have a measure of angle 1, we can actually substitute measure of angle 3 into the measure of angle 1 spot. So instead of measure of angle 1 plus measure of angle 2, it's measure of angle 3 plus measure of angle 2 equals 180. And the reason for that was substitution. Now we're very, very close to the end of this proof. If we know that the measure of angle 3 plus the measure of angle 2 is equal to 180, how does that help us prove that 2 and 3 are supplementary? Well, we're ready for the last line, because if measure of angle 3 plus measure of angle 2 equals 180, if they equal 180, then angle 2 and angle 3 are supplementary. And the reason we know they're supplementary is because they equal 180 degrees, and that's what supplementary means. That's the definition of supplementary again. Now it is a 7-line proof, but M is parallel to N, and angle 2 and angle 3 are supplementary, are basically given to you. What you're given and what you're trying to prove are guaranteed to be the first and last lines. What goes in the middle is a little trickier, but there are patterns to follow. So for example, once we say that angle 1 and angle 2 are supplementary, we then use the definition of supplementary almost every single time. And if we're trying to prove they're supplementary, well then the line above that is that they add to 180 because of the definition of supplementary, almost every single time. If you find these patterns and you're willing to follow the patterns, it'll make your proofs much easier for you. So let's look at the second proof we have here. Given angle 2 is congruent to angle 3, angle 6 is congruent to angle 4, and we're trying to prove that AB is parallel to ED. Now from the very beginning, we're trying to prove that lines are parallel. And if you're trying to prove that lines are parallel, then we're going to use a converse. We just have to figure out which one. So we have angles 1, 2, 3, 4, 5, 6, and this shape that kind of looks like an hourglass. And we're going to do a 2-column proof. So the statement and reason just as before. Now it's a little bit up to you. I like to do one given at a time. So I'm going to start with angle 2 is congruent to angle 3, and that's given. Now we're also going to have 6 and 4 congruent. The question is, can we connect angle 2 congruent to angle 3 with angle 6 is congruent to angle 4? Can we use the transitive or the substitution property? Well, no, because 2, 3, 4, 6, they're all different numbers. But looking at this picture, is there anything that connects angles 2, 3, 4, and 6? Any relationship in the picture that maybe they're not telling us over here, but is evident in the picture? Well, yes, there is. If you look, there's a relationship between angle 3 and angle 4. Angle 3 has to be congruent to angle 4 because they're vertical angles. And that's the vertical angle congruence theorem. Very, very similar to what we used up in this first picture, where we had angle 1 and angle 3 were vertical, so they were congruent. Down here, angle 3 and angle 4 are congruent because they're vertical. Well, now we have line 1 and 2. Angle 2 is congruent to angle 3, but angle 3 is congruent to angle 4. So what that means is that angle 2 has to also be congruent to angle 4. And the reason is the transitive property. So we know angle 2 is congruent to angle 4. But we've actually not used all of our givens yet. We're also given that angle 6 is congruent to angle 4. And that's given. So angle 2 is congruent to angle 4, but angle 6 is congruent to angle 4. Well, since they both have an angle 4, we can use the transitive property again. To show that angle 2 has to be congruent to angle 6, since they're both congruent to angle 4. Now the picture becomes a little confusing here, because when you look at it, all we actually see are line segments AB and ED. Those are the ones we're trying to prove parallel. But we have a relationship now between angle 2 and angle 6. So I challenge you to think of a slightly altered picture. Think of this picture here. There's AB, there's ED, and here's the line that makes angle 2 and angle 6. Be A, B, E, D in the picture. We ignore the other line from A to D, and we just focus on this picture. Angle 2 and angle 6. Look, they are interior to AB and ED, inside, and they're on opposite sides of a transversal. Angle 2 and angle 6 are alternate interior angles. And what we just showed on line 5 is that angle 2 is congruent to angle 6. Well, if angle 2 is congruent to angle 6, and they are alternate interior angles, that means that AB must be parallel to ED. And the reason is the alternate interior angles converse. The interior angles are congruent, so the lines must be parallel. That's the converse, and we've now finished the proof. AB is parallel to ED.